Hello, and thanks for joining me today. My name is Peter Heinrich, and I'm a developer evangelist with Amazon. Of course, you may ask what that even means. I'd say the best way to describe my job is part engineer, part tech support, maybe a little marketing thrown in, but basically, if you work with any Amazon hardware devices or software services, I'm the one there to answer questions and provide example code and generally direct you to the right resources. Now, it happens that my background is actually in game development, which is why I'm here to talk about game development services today. And even though I've been doing this for 25 years, which is a really long time, I still get excited for new technology like our brand new GameOn service. We just announced it a week ago Monday at GDC, and I love talking about this new service we just released and getting into the nuts and bolts because I like to tech out or geek out on the tech details. So hopefully you do too, because that's what this webinar is all about. I'm going to be showing some code, really because I think it's the best way to convey a sense of how you might use this service in your own games. So let's get some basic webinar housekeeping out of the way. First thing you should know is how to deal with software problems during this webinar. So if you ever have any issues like glitchy video or audio or unusual slowdowns, just hit this little reset button. It'll usually make everything clear up, and you shouldn't have any issues after that. Please feel free to ask questions. I'll do my best to answer them at the end in the time allowed, but I'll also follow up with you afterwards if I'm not able to address your question in the webinar. And of course, you can always reach out to me on social media or via my email address. My Twitter handle is peter.games. My email is simply heinrich@amazon.com. Before I go any further, though, let me clarify something. You're going to hear me use the terms competitive play and community a lot, so you might naturally assume that esports is going to work its way into this conversation. But this new service is actually kind of orthogonal to that space. It grew out of our experience with competitive PC games, many of which are immensely popular as esports, but the driving force was actually wanting to bring to mobile something that we thought was missing. So what is that? Well, it's competition with something real at stake, and Amazon GameOn brings that competition to your games via digital and real-world prizes. So it doesn't matter what category or genre you're in, GameOn is cross-device, it's cross-platform, and it does all the heavy lifting: setup, execution, fulfillment, which of course just means delivering the prizes. We make it easy for you to create and manage these one-off and time-bound competitions or multi-round events where, say, only the top players advance, or league play, competitions limited to a specific location or locality, whether that's a country or a city or even a neighborhood, or competitions that are only open to players matching certain criteria that you get to specify. And driving interest and engagement are the prizes. It's your ability to award actual real-world physical prizes. Because if there's one thing that we do know how to do well, it's actually delivering stuff. And people love getting stuff in the mail. It's just how we're wired. We like to compete and compare ourselves to others, and we like to get packages in the mail. So what does this actually look like, practically speaking? Well, you can check out a lot of the great GameOn integrations on our website, but for today I thought it'd be informative to show how you might incorporate GameOn into a simple game written in Unity. So we're going to see if this is working. I'm going to try launching this. So, okay, well, I mentioned before how competitive PC games help to inform our decision to create Amazon GameOn, and it's pretty clear why. Looking at this list, you can see that of the top 10 highest grossing PC titles in the US, 9 can be considered competitive in that they actively support player versus player gameplay, tournaments, brackets, or league play, and really even Minecraft, the one game not identified on this list as quote-unquote competitive in that way. I mean, I sort of get that, but there are lots of super fun third-party MOBAs built on top of Minecraft, so I think I would classify it as competitive as well. We also saw a lot of evidence that mobile games, though not traditionally competitive in the same way as PC titles, stood to gain just as much in popularity and engagement and revenue if they incorporated competition in a similar way. So there's nothing inherent to mobile to prevent that kind of success. And as an example, you can look at this data on one popular mobile game that introduced tournament play, and you can see how several key indicators improved significantly during their tournament week, with a spike in viewership on Twitch, driving a bump in revenue early on, followed by a healthy lift in downloads. And that lift actually takes some time to fall off. So that's the rationale for Amazon GameOn, and today I want to give you the 10,000-foot view, describe how to get started with the service, show some code for the typical use case, and touch on the operational aspect of managing competitions. So let's start with the high-level view. Amazon GameOn offers 3 main pieces of functionality that are related to competitive gaming, including competitive gaming on mobile. First, it allows you to easily set up competitions and define prizes. It manages all the details of device registration and player authentication, including fraud prevention and identifying abuse. And finally, it handles scorekeeping, as well as entry requirements and, of course, prize fulfillment. Under the covers, the service is a collection of web services running on AWS, so it's a robust, scalable, reliable solution, and it performs well even under load. It exposes its functionality through a set of REST APIs that are accessible directly from client devices like tablets or PCs or mobile phones, or from your backend if you have a server-side component. Its REST interface is what makes it platform and language agnostic, so any device or operating system capable of communicating over HTTPS can use GameOn. We don't force you to use any custom SDK or library to access the service. You use what works for you in whatever language that you like best. I actually use it from the command line, from the bash command line quite a bit, just because it's a super handy, low overhead way to play around with the service, even before I've written a single line of code, and it greatly simplifies debugging. So we use Amazon API Gateway to expose the service endpoint and define the interface, which means that you can use a third-party tool like Swagger.io to programmatically generate model classes for the API. So Swagger is great because it supports just about every popular programming language out there, as well as quite a few esoteric ones. Of course, you can roll your own code as well, if you prefer. Today's examples won't depend on any auto-generated classes, but that approach is definitely convenient, so it's something well worth looking into. Okay, so how do you get started with Amazon GameOn? Well, the first step is to set yourself up as an Amazon developer at developer.amazon.com. If you're already an Amazon customer, which is probably likely, you can actually log in with whatever email that you use for that. Of course, you can create a separate developer account as well if you prefer. And then as an Amazon developer, you now have access to our developer portal, which is where you enable services like GameOn and manage their settings and obtain the security credentials you'll need to call the APIs from within your game. So after letting us know a few details about your game, like its title and what category it's in and its price, you can turn on access to the GameOn service. And when you do, we'll provide you with 3 special keys, which we'll also send to you in email. One is our own public encryption key, which you can use to encrypt data that you send to us when the service needs it to be secure. And we sometimes refer to this as the game public key. Then there's an API access key, which is unique to your game that you'll include in most requests that you submit to GameOn during typical use, like when submitting player scores or retrieving leaderboards, that sort of thing. And finally, there's a companion API access key that connects you to certain administrative functions that you don't normally use during regular gameplay. And I'll talk a little bit more about this later on. You can enable or disable access to the GameOn service for each of your games independently, and we'll generate a unique set of security keys for each one. This guarantees that some other developer won't accidentally or intentionally submit their player data for your game or award your prizes to their users. Your game is the only one that can access your game's data. So here's our game. We've got the credentials we need for it to use GameOn. And with those three keys in hand, we're ready to start making calls to the service. Now, as a brief aside, just keep in mind that everything I'm about to cover is documented in detail on our developer portal. And once again, that's simply developer.amazon.com. You can find everything you need to know about GameOn, competitions, prizes, as well as links to our developer forum, videos, and sample code. The first step in using Amazon GameOn is to establish a secure communication channel between your app or your backend and the service. Now, whenever a player connects to GameOn via your game from a device that we haven't seen before, we'll provide you with a unique token, which you should store locally and keep private. How do we get it to you? We provided you with our public key when you registered your app with us, so you can send us private messages, but not the other way around. So to get around this, you'll need to generate a public-private key pair so we can communicate securely in both directions, although you should only have to do this one time for each new device. We can use the public key that you generate to encrypt the token that we generate for you, which you then decrypt using your private key from the pair. And you'll use this token whenever you want to establish a new GameOn session from this device. Many frameworks and operating systems have built-in utilities for working with public key encryption, but if you've never used them, the process can be a little confusing, so it's probably worth walking through each step. First, find out what encryption functionality is available on your target device. Bouncy Castle is one encryption library that's widely available on many systems in the event that you need to use a third-party option. But regardless, use the tools you have to generate a 1024-bit RSA public-private key pair. Next, use the game public key we sent you to encrypt the public key that you just generated. Use the register player API call to send that encrypted public key to Amazon GameOn. And here, I'm doing that via the command line just as an example, but your game will normally do this programmatically. We'll create a unique token for the current device, then send it to you encrypted using the public key that you just sent us. You can then use your private key to decrypt that token. Now that you have the unique token that we generated for this device, we need to make sure that no one else can snoop it when you pass it to us. So encrypt it, again using the game public key to protect it from eavesdroppers. And finally, store this encrypted token for later use. It's valid whenever you want to start a new GameOn session from this device. You can also dispose of the public-private key pair that you created earlier because they won't be needed anymore. So, like I said, not too terribly complicated, but if you haven't had to do it in the past, maybe a tad unfamiliar. There's enough to it, though, that I did write a little helper class that I can use from Unity. It's just a wrapper for some bouncy castle calls. Of course, you could substitute your encryption library of choice. I do highly recommend against rolling your own public encryption key code, though. It's just better to rely on the professionals to do this right. In my case, Bouncy Castle makes it pretty easy. I use their public key factory to unpack the public key that I got from GameOn and store it for later use. Then the RSA key pair generator class spits out the public private keys that we need. The helper class has some additional methods to streamline the encryption steps of the key exchange, such as when we need to encrypt the public key that we just generated before sending it to the service, and when we decrypt the token we receive in return, then re-encrypt it before storing it for the long term. Again, not too complicated. It's 3 or 4 lines of code in each case, but it's handy to have it in a utility class. Once we have that token, we can use it to initiate a GameOn session whenever we want. We authenticate the current user to the service, and we'll receive a session ID in return. So for the game code we're looking at today, remember I mentioned we would not be using auto-generated interface classes. I did, however, create some convenience methods to pack and unpack our API calls over HTTPS. So for example, this authenticate method. And here's how authentication works. First, I look in local storage to see if I have the token I need. If not, I go through the key exchange process that I just described, which is handled by a method I call register player. If successful, that call will store the token locally and I can proceed. I created some classes to represent the GameOn data model encapsulating the parameters we send for each request. So in this case, the auth player request object includes a parameter for the token we need to send, as well as fields for other data that the API expects us to provide. Now I can send the request to the GameOn service, passing some callbacks to process the response or deal with errors if any occur. If the call succeeds, we'll get a JSON response, so I have another model class that knows how to instantiate itself from that JSON, giving me access to the data it represents. In the case of authentication, we especially care about the session ID, which we'll use in subsequent calls. If the call fails, we'll get an error message that we can display or log. Once we have a valid GameOn session, the player can now start interacting with competitions. And as I mentioned earlier, since GameOn is an API and not an SDK, it's up to you how you want to represent key aspects of the service features. So for this simple Unity game, for example, I just added a tournament button to the main menu. When the player clicks it, an overlay appears showing the active tournaments that I've set up, which allows the player to choose from between them based on the amazingly compelling titles that I've attached to each competition. And this kind of UI is pretty trivial to build in Unity. We just need to retrieve the information about each tournament so we can create the UI components for display. So to get that data, again, I've created a model to represent the actions that we want GameOn to take, in this case, retrieving a list of tournaments. And it's derived from a generic request object that I defined that stores the URI associated with it, but not much else. The derived classes keep track of the specific data required for each type of request, named according to what GameOn expects to see in the JSON body that we send to it. The constructor sets the URI corresponding to the REST API for this request, and then with the request object defined, I can again wrap the HTTPS communication call in an API-specific utility method, passing the callback actions for success and failure conditions just as I did for authentication. In this case, a successful call will return a list of tournament objects that were deserialized from the JSON response. And what do those look like? Well, again, I've created some classes to model the response and the tournament information that it contains. This is actually one of the supreme advantages of using a code generator like Swagger, because it would generate all these classes programmatically from an API definition file, which obviously goes a long way toward reducing errors and making it easy to update your code if the API changes, which is unlikely, but if it were to happen, Swagger would insulate you from that. For this call, we get a bunch of data for each active tournament, and there's a lot of information that we receive that we can display to the user, including the tournament title, the start and end dates, maybe even an image. We can even show the potential prizes as well. So using the unique ID associated with each tournament, we can retrieve additional details about the tournaments. If we want that extended data, we make another call to the GameOn service, processing the response in a similar way to populate an object with additional tournament details. Notably, we want to get this list of prize bundles. And a prize bundle, as you can see by the definition below, just includes the title, the description, the image, essentially everything we need to display an enticing, browsable catalog of tournaments for the player to choose from. Now, when the player expresses interest in a particular tournament, we can create a detail page for it, which might include the prizes that are available, and I'll also add a prominent play button so they can go ahead and dive right into the competition. To actually enter tournament play, we need to add the player to a match. So if we look at the typical interaction model, we've reached this point where the player has chosen to join the competition. Now, calling the API in essentially the same way we did previously, we'll post a request to enter the competition specified by tournament ID, passing along the current session ID as well. If successful, GameOn will return a match ID, which indicates that the player has been admitted to the competition, and we can now submit scores. Now the game takes its normal course, the player plays, we track their performance, and when we consider their attempt complete, whether that means they finished the level, or they lost a life, or they achieved some status, when they're done doing whatever it is that we've set out for them to do, and we can score that activity, we post that score back to the service using the same match ID we received earlier. Now for this example, I've created another screen in Unity to show the player's current standing after each run. It's just a simple leaderboard in this case, but we could easily combine this data with other details about the competition. So GameOn allows us to limit how much leaderboard information is returned to us, so we can page through the results if we want. We can also specify how many other players we see that are close in rank to the current player. The data we receive will include rank, name, and high score for the match leaders, the current player, and the close neighbors. So we can add all this data to the UI, and then depending on how you set up your competition, the player may be allowed to submit multiple scores, each of which is considered one attempt. If the player hasn't used up all their allowed attempts yet, we'll make sure that they can jump right back into the action and try again. So here's where we just were. The current player played one match, we submitted their score, then we retrieved the competition leaderboard and showed their standing. Now, as long as the player has attempts remaining, we can continue the sequence as long as they want. Play, submit score, show standing, play, submit score, show standing. And the original match ID is how the GameOn service keeps track of those attempts. The match ID returned when a player successfully enters a competition is good for as long as they want to participate. So each time you submit a score on the player's behalf, you should provide the original match ID. When you, as a developer, set up a competition, you can define the maximum number of match attempts that are allowed by any single player. So when those run out, no more scores will be accepted for that player. However, you can selectively add to that attempt number that they have available. And you should note that GameOn defines two different API calls for entering a tournament and replaying a tournament, essentially differentiating between the first match and subsequent replays. And it's really just a minor detail to be aware of when more than one match attempt is allowed. So once a competition expires, or you terminate it manually, which is also an option, GameOn will calculate the winners and award prizes as appropriate. It does this automatically, handing out prizes to the top players based on how you define your competition. So you can see which prizes have been awarded to the current player by retrieving match details for that original match ID I just mentioned. By now, this pattern should be pretty familiar. It's a request object. It encapsulates parameters appropriate to the API call. In this case, the important detail is the match ID. So a companion method wraps the HTTPS communication, handles packing the request and unpacking the response. The getMatchDetails response object includes lots of information about the player's current progress in a competition, including, if the competition is complete, details about any prizes that they've been awarded. Note that prizes that are awarded aren't considered actually delivered automatically, so GameOn requires that you explicitly report when a player claims an awarded prize. And this is to give you the opportunity to record the entitlement yourself when appropriate, such as when you need to unlock an in-app item or deliver a digital asset that you control access to. For physical prizes fulfilled by the GameOn service, though, it also prevents unwanted deliveries. Anyway, it's a safety feature, so you should plan on providing an interface that shows the player what they've won and gives them a way to officially accept the prize. The REST API allows multiple prizes to be claimed at once. You just have to supply a list of the awarded prize items. And the response you get back will include a list of all the prizes that were successfully marked as claimed, as well as those that couldn't be claimed for some reason. So, how do you go about actually setting up a live competition? There are currently 3 ways to create competitive events in your game, starting with the GameOn console on our developer portal. It's really the primary interface that most game developers will use to manage competitions through the GameOn service. It has a user-friendly interface, makes it easy for you or your community manager to set up events, create prize bundles, and review reports on your GameOn integration. There's also a separate administrative REST API, a companion interface to the one I just described for use in-game. So earlier I mentioned how one of the security keys that we generate for you unlocks features not normally used during regular gameplay. And those features are part of this admin API. It allows you to programmatically create and manage competitions and prizes, which can be handy if you want to run repeating events, for example, or if you regularly deal with a lot of events at once. And finally, there's another option based on a powerful feature that I didn't demonstrate in my little Unity example, but that is, you can actually enable player-generated competitions within your game, giving your users the ability to stand up ad hoc events and invite others to compete. So these player competitions are similar to the ones that you create as a developer, with a few restrictions. Players can't attach prize awards, for example, or specify complex entry requirements. They can make their competition private, though, in which case GameOn will generate an access code that they can share with friends and family. If you have players streaming your game, letting them set up custom events is a great way to amplify your impact. It gives your fans a lot of flexibility, which is always good when you're trying to build momentum and get the word out. So of those 3 options, the GameOn console is probably the most common way that you'll interact with competitions that you create for your players. As I mentioned, it has a straightforward interface, makes it easy for anyone on your team to set up the events or prizes. You can set time limits, add restrictions on who can enter, monitor the leaderboard, check on prize delivery, etc. Basically any operational task that you might want to perform with respect to GameOn competitions can be handled from this console. If you do have a community manager, this gives them the ability to manage the whole competitive gaming aspect of your game without the need for any developer support, which is super handy. And just to give you an idea of how you'd accomplish some of these tasks, in the tournament details section for each competition you set up, you have the option to make it recurring, meaning it will reset itself on a regular basis. Players can rejoin, whether they won or lost the last time, doesn't matter, for a chance to compete again for the same set of prizes. And this is really useful if you want to have a weekly or monthly prize, for example, and you don't want to have to manually re-enter all the competition data every week or every month. This is also where you control the entry requirements that I mentioned earlier. So by default, any player can enter competitions that you create, but you can restrict access according to country or GPS location or custom criteria that you set up. So here I've changed player eligibility to allow competitors from 3 specific countries only. If someone outside of the US, UK, or India tried to enter your competition, they wouldn't be allowed to join the match. And this also applies if you restrict access to some radius around a specific GPS location or require participants to satisfy some list of custom requirements, like having a certain minimum score or even a particular inventory item. The GameOn console also allows you to set up those real-world prizes that I was describing earlier. and these are the things that you want to award to your winning players. They have to be items that are sold or fulfilled by Amazon, so you'll have to choose from, I don't know, tens of millions of items. Honestly, if you can't find a suitable prize on Amazon, please let me know. I'd be really curious to know what kind of prizes you're looking for. So that's it for the GameOn console, which, like I said, is probably how you'll do most of your GameOn configuration. However, in some cases, you may want to create tournaments or tournament series from code. I didn't really talk about tournament series specifically, but they might include those multi-round tournaments that I mentioned earlier. So, as an example, a series of tournaments where only the top finishers advance to the next round. So for those situations, you can use the admin API. It basically exposes the functionality of the GameOn console to your code, so you can do all your configuration programmatically. Like I said, this is not required at all. Most games won't use it, but it is another option for controlling how the GameOn service operates inside your game. And that's it for my whirlwind introduction to Amazon's brand new GameOn service. So what's next? Well, GameOn is actually just one part of Amazon's wider involvement in game services and game development. We have a lot going on, and we call the whole collection of projects simply Game Tech. If you want to take this conversation to the next level, you should check out everything that we have to offer. So that includes infrastructure that we provide, like game servers, analytics, core backends, even implemented on AWS. The Alexa Skills Kit is another good example. It also includes pre-built game services and tools like GameLift, GameSparks, or development tools from TwitchDev. Of course, GameOn qualifies in this category. Then there are resources for game content creation, like our free AAA game engine, Lumberyard. And finally, we can help with distribution and marketing across Amazon.com, the Amazon App Store, and Twitch. So thank you very much for staying with me. I'm glad you were able to join me today. I'm going to take a few minutes to review the questions that have been submitted so far. And if you don't have a question or you want to get on with your day, thank you so much again for joining me. Otherwise, hang on for just a few minutes and we'll have our Q&A session at the end. Thank you very much.